So, in essence, what we are trying to do is basically to have a way to know when the parent begins, sorry, to have a way such that parent begins, starts running, starts the child. When the child finishes, the parent starts running again, and the parent ends. Okay, so let us basically ask a question based on what we have studied so far. How many shared variables do you think we need in order to implement a condition variable where basically the parent can wait for the child until it's done? Well, we will cover how many variables that you need again, but it's basically one because that's basically what we studied so far, and we will basically look at the logic behind this implementation. One simple implementation for a parent to wait for its the child is basically to have a variable that is basically shared between the parent and the child, like done. And basically, while the child uh, is running, done is equal to 0. Once the child is done, it sets done to 1, and then it returns to the parent. And then the parent spins on done equal to 0, and if that value does not change, then the parent knows that the child is still doing processing. Now, this is a bad approach for multiple reasons. The first one is basically that if you start thinking about multiple children, which is the case in most uh, threading that you will encounter in your life, otherwise it doesn't make sense to even have a single thread running, then it becomes very, very complicated to have done changed, because one child might finish while the other child might will not finish. So you will have always synchronization issues even between these values. The second reason this is a bad idea is that spinning is in general a way that wastes your processor time, because now the processor does not have does has no way to know. A processor will never have a way to know if that parent requires processing time or will it just waste it spinning. And if you're using something like round robin, for example, the processor has no way to know if what you're doing is CPU burn, basically you're spinning on nothing while one, basically, or if you're doing actual work as a thread, which basically means that the processor will schedule the parent, and the parent will take its whole quota doing nothing, while that quota could have been used by one of the children to actually make progress, and then finish work. So spinning is in general a bad way of doing locking in a system. You do it sometimes, like in the spin locks case, but that's basically because that is one of the very primitive ways to do locking. So you might need to use it. So what we are going to try to discuss today is how to wait for a condition in a multi-threaded uh, program, basically. So condition variables have a very crisp definition, which is basically an explicit queue that threads can put themselves on when some condition is not true and thus requires the thread to wait on that condition to be satisfied. Okay, so it's basically a data structure, a queue data structure, where if a thread is waiting on a condition, be it a parent thread or a child thread, if a thread is waiting on a condition, it just moves itself into this queue, the waiting queue. Okay, and this is a queue that basically gets the threads in that queue will get waked up or will get scheduled only when the condition is true. Okay, so instead of the operating system basically running a spin, basically not knowing what the child is waiting on or what the parent is waiting on due to spinning, this is a way to tell the operating system that everything in this queue will do no good work, will have no progress unless this condition becomes true. So you set a condition, sorry, and you wait for it. And then once the condition happens, basically the condition is satisfied, you basically wake up these threads in the queue, okay, and thus allow them to continue. So you give a signal. So basically, when you're doing parallel programming using condition variable, you have to think of, well, I have a condition and I have signaling, and you have to understand the logic, okay, that once this condition occurs, I have to signal for the others to wake up. And as long as this condition does not occur, these threads need to wait for that condition to occur. Okay? In some sense, this is also a way to give some of your threads some priority because, well, now all threads that really need that condition will never be scheduled. They will be in the waiting in the queue. And only those threads that can help progress this condition will be scheduled. Okay? Or at least the set of threads that are required for this condition to occur will basically do progress. And once they are done, once they are finished, you give a signal.